Hai, Assalamualaikum dan salam sejahtera. Today we want to talk about the one hot topic actually in engineering mathematics 2. So the topic is differentiation. So guys, keep focus and take note the point, okay?
Assalamualaikum. So I want to intro my teammates. First, Muhammad Aidil bin Muhammad Kanafiyah. Second, Ahmad Afif Afnan bin Muhammad Kamaruzaman. Third, Muhammad Zulhilmi bin Rosman. And last, Muhammad Aswad bin Muhammad Rasdan.
Alright, for the first one is introduction for differentiate. I think you guys know about this topic, but let me explain in details, okay? So differentiate is typically involve understanding the concept of slope of a curve at a point and how it relates to the derivative of a function. So the derivative given the slope of the tangent line to the curve to any point, thus providing information about the instantaneous rate of change of the function at that point.
Hello, my name is Muhammad Zulhilmi bin Rosman. My matrix number is 01 DEE23F 1046. So I'm going to explain about formula of differentiation. So in this slide we have 5 formula. First we have constant rule, which is d over dx in bracket c minus 0. Next we have sum rule and difference rule. The equation is d over dx in bracket fx plus minus gx equals function x fx minus plus minus gx. The third one we have multiple constant rule. The equation is d over dx in bracket c gx equals cgx. For the fourth one, product rule. The equation is d over dx in bracket fx dx. So fx times gx plus fx times gx. Next we have chain rule, d over dx fx square n equals n fx in bracket fx square n minus 1. Last we have quotient rule, d over dx fx over gx equals function x dx minus second function x fx over gx square.
Okay, so next is about application. Engineers we choose is engineering and finance. This one is engineers use differentiation to solve problem related to optimization such as maximizing the efficiency of system while minimizing costs or maximizing the strength of a structure while minimizing material usage. So additionally, differentiation is used in electrical engineering for analyzing circuit, signal processing and control system. Analyzing circuit, for example, difference between series or parallel circuit that we know. Parallel circuit current through in the circuit constant. The second one is about signal processing. For example, we probably can see at oscilloscope that show a signal through waveform. Okay, secondly is about finance in application. In finance, differentiation is used to calculate rate of change in financial quantities such as interest rate, asset price, and investment returns. Derivatives play a significant role in financial modeling, risk management, and the pricing of financial instruments such as optional and futures contracts. I'll give some example. It's about a goal, and sometimes the price is increased, or we don't know, next year the price is decreased. Another example is I give you about we build or we buy a house. We look at that location. Sometimes price is increased higher. Sometimes is lowest decreased price.
So I'm going to explain the solution of question E. So the equation is y equals 4x squared 3 plus 9x squared minus 12x minus 5. We put this as a first equation. Then we do the differentiation. We just differentiate the first equation. Then we get dy over dx equals 12x squared plus 18x minus 12. Consider this as a second equation. After that, we factorize the equation. Then we get 2x minus 1, x plus 2. Then just put this as a equation 3. Okay, for the stationary point, dy over dx equals 0. We just do the basic algebra. 2x minus 1 equals 0. So just move the negative 1 to the other side. So we get 2x equals 1. And move the 2x and move the number 2 to the other side. So we get x equals 1 over 2. For the next equation, x plus 2 equals 0. Just move the number 2, so we get x equals negative 2. Then substitute x equals negative 1 x equals 1 over 2 in equation 1. So the equation 1 is y equals 4x squared 3 plus 9x squared minus 12x minus 5. Just substitute 1 over 2 in x. So we get y equals 4 in bracket 1 over 2 square 3 plus 9 1 over 2 square minus 12 in bracket 1 over 2 minus 5. So the answer, just calculate in calculator, then we get negative 30 over 4 or negative 8.25. Then next, substitute x. We must do the second equation. So substitute x equals negative 2 in equation 1. It's same as first substitute. So just substitute the negative 2 in x. So we get y equals 4 in bracket negative 2 square 3 plus 9 in bracket negative 2 square minus 12 in bracket negative 2 minus 5. The answer after calculate in calculator, we get 23. So we get the stationary point. For the first stationary point, we get 1 over 2 for x and y, negative 33 over 4. Then for the second stationary point, we have negative 2 and 23, x negative 2, y 23. After that, we do the second degree. So just take from the equation 2, which is after differentiation. So dy dx, we get the equation for dy dx. dy over dx equals 12x squared plus 18x minus 12. So do the second differentiation, d square y over dx, we get 24x plus 18. For the last one, for the point, we just do from the x equals 1 over 2 and x equals negative 2. So just substitute in the second degree differentiation equation. So d square y over dx equals 24x plus 18. Substitute 1 over 2 in x, so 24 in bracket 1 over 2 plus 18. So we get the answer is 30. So 30 is more than 0. So the point is minimum. Okay, at the point x equals negative 2, just substitute in our second degree equation, second degree differentiation equation. So d square y over dx equals 24x plus 18. Substitute in negative 2 in x, we get 24 in bracket negative 2 plus 18. The answer after calculate is negative 30. Negative 30 is less than 0, so negative 30 is maximum point. That's all for me.
So I want to talk about equation. First step, differentiate the equation. After differentiate, get the answer for value for x. After that, from the x answer, we get from the equation fill it to the equation back to get the value of y. So we can, the stationary point is 1 and 2. After that, we differentiate again from the equation and we get cx. Fill it as value to the equation that we differentiate and get 6. So the minimum point is 6 is more than 0. Second step is intersection of the axis. X equals 0, y equals x squared 3 minus 3x plus 4. Substitute 0 in equation equals 0 squared 3 minus 3 magnitude 0 plus 4. The final answer is 4.
So now we talk about the next slide, which is a summary. So my friend already told and present all your slide and point. So now I want to list down the important thing and the important idea lah. Right? So I list down 4 points for our summary in our slide. The first one is differentiation can be applied in our daily life. I think the last slide, my friend already talk about the how to applications how to apply differentiations in our life. Okay, so the second point is differentiation in a finance can show us up and down financial. Okay, so the third point, by using the differentiations, we can solve problem in engineering, financing, and also we can solve is by using differentiations. And in math, we also can sketch the graph from the result calculation. Okay, so the last point is it's important to study about differentiation because most of our daily routines need a differentiation for life. Thank you.